STEM fans, are you ready? Let's hear it for the world-class NASA STEM Stars team. From NASA centers across the country, we present Doug Hofmann.
Good afternoon and welcome to another episode of NASA STEM Stars. I'm Jen Hudgens from the Kennedy Space Center, and today we have Doug Hofmann from JPL. So welcome today, Doug.
I'm well. Thanks for hosting me.
Yeah, absolutely. So this 30 minutes is going to go by really fast. So like I just told our viewers, we're going to do a little deep dive into your career out at JPL. But before we get to that, can you tell us a little bit about your background, where you grew up, maybe some of your education?
Sure. So I'm from Santa Rosa, California, originally born in San Francisco, grew up in the Bay Area, and I went to Santa Rosa Junior College for my first 2 years of college, and then transferred to UC San Diego for my bachelor's and master's degree in mechanical engineering, and then on to Caltech, the California Institute of Technology in Pasadena for another master's degree and for my PhD.
So I see some pictures there. It looks like you were wearing a basketball uniform, and there's one of you playing tennis. So were those interests of yours in high school?
Yeah, I came from kind of a non-traditional STEM background in that I was an athlete. Although I did play basketball in high school, mostly I was a standout tennis player. So, I went on to play tennis in junior college at Santa Rosa Junior College, and then later for the NCAA at UC San Diego. So I come to NASA from the NCAA athletics background, which is sort of a non-conventional path to end up at NASA.
Well, that might be really helpful for students to know, because there are some great athletes out there that are also pursuing, STEM degrees, and that might be a bit of an encouragement for students out there. So thanks for sharing that non-traditional type background and path into NASA. Did you have any other interests in high school?
Yeah, I mean, mostly in high school, I was known for being an artist. I didn't take any honors or AP classes except for AP Art and AP Spanish. I actually got a 5 on the AP Art exam, which I'm told is quite difficult. So, I really had set up for a career in art as opposed to a career in science and engineering. I only made the switch into science and engineering once I was already in college, and it looked like a more employable route for the future.
That is an amazing piece of art there. And tell us a little bit about this picture here.
So I went to a brand new high school, Maria Carrillo High School in Santa Rosa, California. And when I was in middle school, they had a contest to draw the mascot for the high school. So I won that contest as a ninth grader or 10th grader. And then the new principal of the high school put the mascot into marble on the gym floor. So it's been 20 years plus since I graduated from high school, but the mascot that I drew as a 15-year-old is still on the floor of the gymnasium at the high school. So that's really cool to have. And my high school is now known for having a famous Olympic athlete at it, Maya Dorado, who competed in the Rio Olympics and won many gold medals, is a graduate of my high school as well.
Wow, that's probably very cool to still be able to say that. Do you think your kids are going to be able to visit that and see that someday, or do you live close by still?
I don't live that close anymore. I live in Southern California now, near Pasadena, where the Jet Propulsion Laboratory is. But Northern California is, a 7-hour drive away, and I have deep roots there. So.
That's awesome. So tell me, did you have any mentors in high school? I know you mentioned that you were going to be going into art when you started pursuing your bachelor's, but when you got to college, did you have any mentors that may have pushed you towards a STEM degree, or what made you make that switch?
Yeah, so that switch happened for me, kind of my freshman year where I was attending junior college. I had straight A's in high school, but I wasn't, doing any honors classes or AP classes in sort of STEM fields. So it was sort of a discussion, with some family members, my mom, where I was advised that if I was good at math, I should probably go into engineering as opposed to going into art, just because it seemed more employable. So for me, I just kind of arbitrarily signed up for engineering classes my first semester in junior college, and signed up for the engineering track, which ultimately resulted in my AS degree in engineering. And then that was kind of the pathway to transferring to UC San Diego, where I got into the mechanical engineering department. So it was not a traditional route where a lot of students are doing robotics and STEM as very young ages, doing math bowl competitions and so on. I did not come from that kind of background. I came into science and engineering as an adult, which is, again, not traditional.
Yeah, so you had a lot to learn getting going from the bottom. So you, I would think though, as an adult, you probably learned a little bit easier because you're a little more dedicated than maybe as a high school student, being shown all these different sciences where you had your track, like that picture we just saw, where you get really hands-on practice in a true lab and then, realize
Well,
which part of engineering that you liked.
yeah, I have to hand it to Santa Rosa Junior College and UC San Diego and Caltech. They really molded me into a scientist and engineer pretty much from a blank canvas. So that's why the colleges are there and why they have rigorous academic programs. So I do have some blind sides as a NASA scientist. I'm not as good with CAD software and robotics programming as many other engineers, and that's because I just didn't grow up doing those kinds of things. So I'm much more of a scientist than I am an engineer because of that.
Yeah, oh, I get that. Like Excel came out after I had graduated from college, so it's something I had to learn, further down the road. So I'm sure everybody would understand that story in some aspect or another. So, and I think you brought one of your graduation pictures from college to show us. So we'll put that up, and that was University of California in San Diego. Is that what you said?
Yeah, that's right.
Yes.
That's my graduation from UCSD with my bachelor's degree, and then I got my master's degree the year after. So going to school in La Jolla in Southern California, down near San Diego, was one of the highlights of my life. That was an amazing school. I spent, like I said, a lot of my time playing NCAA tennis and surfing. It was a really wonderful experience.
And then you jumped right into your master's from your bachelor's. Is that what you just said?
Yeah, there's a program called an MSBS program where they allow you to take graduate classes in lieu of electives as a senior undergrad. And then
Oh,
1
nice.
year later, you can take a full load of graduate classes and then write a thesis. And you can get your master's degree in 5 years instead of the typical 6 years that it would normally take from the start of your undergrad degree. So it was a nice year to add a master's degree in mechanical engineering. But then I transferred to Caltech and started over again with a master's degree and a PhD in a different field of material science, which is what I do at NASA now. So I have a set of degrees in mechanical engineering that makes me a mechanical engineer, but I am not a mechanical engineer anymore.
That's great. So before we jump into what you actually do out at the Jet Propulsion Laboratory, we're going to take a little break here for a brand new segment that we've started called the Lightning Round, where it's a segment where I'm going to ask you some rapid fire questions, and you have 30 seconds to respond with a one-word answer. And we're going to see how many questions we can get you through. So are you ready for the Lightning Round, Doug?
Hit me.
All right.
Time for NASA STEM Stars Lightning Round.
All right, so if we can put up the leaderboard from last week and we can see how many questions we need you to beat, get you up. Okay, so we need to at least get maybe 9. Let's try for 9 today. What do you think? All right,
let's
so
do it.
let's put 30 seconds up on the clock and we'll go ahead and get started. Tennis shoes or flip-flops?
Tennis shoes.
Star Trek or Star Wars?
Star Wars.
Homework or yard work?
Yard work.
Pen or pencil?
Pen.
Hero or villain?
Villain.
City or country?
City.
TV shows or movies?
Movies.
Tie-dye or bow tie?
Bow tie.
Introvert or extrovert?
Introvert.
All right, you got 10 questions. You answered 10 questions, and you said introvert. I can't believe
Oh, my
that.
wife is probably going to listen to this and be like, "Wait, what did you say?"
And I love that you said villain over hero, because I'm of the persuasion that you can't have a good story without a villain. So who's your favorite villain?
Well, I've got the Lex Luthor, shaved head book. So.
That's great. All right, Lex Luthor and Superman. Mine is Maleficent from
just watched
Sleeping
that
Beauty.
Sleeping Beauty
Yes.
with my.
Yes.
I just watched that with my daughters, and she is delightfully villainous.
Yes, cannot have a good story without a good villain. So I agree with you there. So, all right. So we got you on the leaderboard. So you lead with 10 questions. So if everybody that's watching today will give us a thumbs up in the chat and congratulate Doug for doing that so well. And we're going to jump right in now to what you're doing at JPL. Can you share with us? You said you're a materials engineer or scientist. So tell us, what does that mean?
So I work at JPL in the Materials Development and Manufacturing Technology Group, which is a group that I co-founded with a couple of colleagues, a number of years ago. And what you see in this picture is the lab that I founded, which is called the JPL Metallurgy Lab. So this is a lab dedicated to the invention of new metal alloys and manufacturing technologies necessary to make spacecraft survive in extreme environments. So it's a lab specifically dedicated to addressing the concerns that we have at NASA about going to different planets or being in deep space, being in high radiation environments, cold environments, hot environments in the case of Venus, and then trying to develop new materials that will be able to more easily handle those conditions than conventional materials. So that is the lab that we work on, and we've got quite a big group of scientists and engineers that work in this effort. More than 20 scientists and engineers that work in this materials and manufacturing effort at NASA JPL. So we do everything from metal 3D printing to machining and casting and injection molding and invention of new alloys. So the best way I like to describe what I do is I'm an inventor. I invent new materials and new manufacturing techniques for making materials so that we can make spacecraft better.
So you mentioned spacecraft. Have you done any work with the rovers? Because I know down at JPL, that's what most of what they're known for is Curiosity, Perseverance, Ingenuity. Have you had a chance to see the rovers or help develop anything that those rovers are built with?
Yeah, the first rover, Curiosity, launched the month after I was hired in JPL back in 2010. So I didn't have a lot of opportunity to work on those other than consulting on some last minute manufacturing problems. And then Perseverance, we worked on it in more detail. I think the highlight of the effort from our larger group on Perseverance was that we have 11 3D printed metal parts that are on the Perseverance rover. So back when Curiosity launched, we had no capacity for metal 3D printing. And now with Perseverance, we've got some critical parts on 2 different instruments. One is called Pixel and one is called Moxie that have 3D printed metal parts in them. So that's a big achievement from our effort, even though I played only a small role in the fabrication of those parts.
Yeah, we actually had a question from a student. Amani wanted to know, have you made alloys from asteroid materials.
Yeah, so that's called in situ resource utilization, or ISRU. And we have not done that yet. Clearly, the easier material to get is from the moon or from Mars. Asteroids are difficult to land on or capture. But yeah, NASA's been working for many years on trying to take regolith, which is the dirt from planetary bodies, and then try to manufacture with it. I know there's an experiment that's going to be on the space station that just launched yesterday, which will be an experiment to 3D print regolith simulant on a 3D printer on the space station that was built by a company called Redwire, that is going to be up there soon. So that's some exciting work to look forward to in the future.
That's great. And another student also wanted to know, do you use a 3D printer in your lab? So I think you kind of answered that, but I'll go ahead and throw that ball into your court.
Yeah. We have 3D printer in our lab, but we also have the JPL Additive Manufacturing Center. And additive manufacturing is just a fancy name for 3D printing, but we've got several metal 3D printers here at JPL that produce aluminum and titanium. And then we use the printers to develop new materials, like materials where we blend between multiple materials together in a single part. And then we also have a very large plastics 3D printing lab. Most people don't know, but we can also 3D print plastics for spacecraft as well, if they're the right kind of plastics. So yes, we do a lot of 3D printing at JPL.
And they also wanted to know, they said that's cool. So you've used regolith in 3D printing, so in your lab particularly, or you just have seen it done?
That's not in my lab, but there is another lab at JPL where they're looking at sintering together regolith to make structures out of. But most of that work goes on at other NASA centers, like Johnson Space Center, not at JPL.
Yeah, I've seen it also at Kennedy, so I know we have a special lab here that also works on that.
It may be Kennedy too. I'm sorry if I misspoke. It's Kennedy and Johnson, or both. I don't know.
It's okay. So what other projects have you been working on?
Oh man, we're doing a lot of cool things. One of the things we're doing is we're trying to develop a gearbox that's made out of metallic glass material, which we hope to be able to put onto the moon, onto a robotic arm that will operate in extremely cold environment on the moon to try to dig for ice and do science experiments. So that's a really exciting project that I'm working on right now. I'm also working with Caltech on a small deployable habitat structure for the lunar surface to try to bury instruments and even people under the lunar regolith to protect them against radiation that you would experience on the lunar surface. And I'm also working on developing the orbital debris shield that will go over our Mars sample return mission, which will bring the samples from the Perseverance rover back home. So we're doing a lot of really fun missions right now that are everything from gearboxes and rovers to spacecraft flying back from Mars. It's very exciting.
I bet you love your job. Have you always known that you wanted to work at NASA?
Definitely not. NASA was not on my radar really until I was at UCSD. And one of the professors at UCSD was Dr. Sally Ride, a very famous U.S. astronaut. And so I started, I recall actually I had a seminar at UCSD by astronaut Greg Lintieres. And, that got me really thinking like, wow, this would be really fun to work at NASA. So when I decided to go to grad school, I specifically sought out opportunities at Caltech and at MIT that were affiliated with NASA. And ultimately, I went to Caltech because of the proximity to JPL. So I'm sort of a late comer into the interests of getting involved with NASA.
Well, it sounds like you and I have something in common, because I've had the benefit of meeting Sally Ride too, and she was my inspiration. So who knew? Who knew?
Yeah, fantastic. I remember. Oh, sorry, go ahead.
No, go ahead. You remember what?
I was just going to say that my dad applied for the teacher in space astronaut job back from the 1980s. So I'm still old enough to remember Kristen McAuliffe, who was the first teacher that was going to go to space and teach from the space shuttle from the Challenger mission. So that's how old I am. In fact, the space shuttle flew the first time the year I was born, and then it stopped flying the day my son was born. I had launch tickets for the last launch of I guess Endeavour, and my son was born that day. Between my birth and the birth of my first son was bracketed.
We had a question from a student that wanted to know a little bit more about metallic glass and whether or not that's similar to silica.
So silica is oxide glass, and the atoms are different, the bonds different. So you can go to Google to look at metallic glass, but it looks like metal. It just has the structure of like a window pane glass, for example. So not all glasses are transparent. Like obsidian is a black volcanic glass that you may be familiar with. Metallic glass is made of elements like titanium and zirconium and copper and aluminum. And it looks like glass, but the atoms are all arranged randomly. So it looks like a metal, but it has the structure of a glass. It's sort of a nuance.
And it seemed like when you were explaining that project, the benefits of using metallic glass was because it can withstand colder climates. Is that correct? Or is there other benefits to it?
Yeah, it has a lot of benefits, but one is that it has very good wear resistance at cold temperatures. So when you make gearboxes out of metallic glass, they can operate in cold environments without having to be lubricated by, like liquid lubricants that we have to use on the Mars rover, for example. So it's a way to make gearboxes that are dry, as we call them.
Gotcha. Another question. Did you do any internships during college?
And that's a great question. And the answer is no. As I mentioned before, I came from the NCAA world, so I was an athlete. So to play NCAA sports, it's a full-time commitment. So I was doing, two different tennis sessions a day, most of the year. And then that didn't leave a lot of time outside of school to do internships when you're an athlete. So I didn't have the opportunity to do any internships. And then when I was at Caltech, I played semi-professional tennis. So that also made it difficult to do any internships. So mostly I got my hands-on work done while an undergrad in the labs, and then later as a graduate student at Caltech, where my 4 years of graduate school was in the lab, building things. So it's, again, a not conventional background to not have done a lot of internships. But for all the athletes out there who think that, you need to be able to do internships to be able to get into NASA, it's not necessarily true. You can be an athlete and still do a career in STEM.
That is great advice. And I hope that we have some athletes watching today that will take your words to heart. So can you tell us what is your favorite part about working at NASA, JPL? What are some awesome things about your job? What have you got to do that's been cool?
Oh my gosh, it's just amazing. Well, I guess I should also apologize for the audio. For some reason, we get some lagging here because we're doing these things remotely, as always. The diversity of the things I work on at JPL. One day I'm working on building a 3D printed excavating tool to cut through ices, which we might experience on the moon of Jupiter, Europa. The next day, I'm doing hypervelocity impact testing, simulating debris impacts on a space vehicle. The next day, I'm doing gearboxes for a rover. So you really, never know what you're going to be working on from one day to the next, and the diversity of things you get to work on is so amazing. It's just never dull here at JPL, and that's very exciting. We also get to have a lot of collaborations with outside institutions and even commercial companies that makes working here really fun. But also the thing that I really enjoy is that I get to do events like this. You can tell that what we do is so exciting to the public that students are willing to sign on and listen to people like me talk about building spacecraft. So the public engagement, that really is what makes it worthwhile, knowing that what we're doing is appreciated by the public. That that makes it really special.
I bet you've met some pretty famous people along the way as well, haven't you?
Yes, I have a collection of pictures of astronauts that have visited my lab. So I've got a dozen or more pictures of myself with astronauts that have come by and visited. When they come by and visit JPL, they'll often go around and see some of the labs, which is fun. And yes, other high-profile people that have visited lab or where we've gone and visited lab. I think my best experience was when I met President Obama back in 2014 when I won the Presidential Early Career Award. And got to go to the White House. And it was not just amazing to meet the president, but I also got to meet the director, or the administrator of NASA, General Charlie Bolden, who flew the space shuttle. And he was on the stick of the space shuttle when the Hubble Space Telescope was put into orbit. And so I got to meet him, and his office made a cake for me and the other award winners from NASA, which was a surreal experience. And then later I got to go over to the White House, which you see in that picture. And President Obama was so gracious to us. It was just, one of the most amazing days ever to go meet those two phenomenal men.
That is so amazing and inspiring. And I'm sure you were inspired as well just by meeting them. So thank you for sharing that. We just have a couple minutes left. So I want to give the floor back to you if you have any last minute words of advice for the students that may be watching and maybe floundering with ideas for their future careers.
Yeah. So I guess a couple, words of wisdom. I don't presume to know the ages of the people who are watching this or who will be watching this. But there are many non-conventional ways to get into NASA, even from art and design background. We have many people at JPL and in NASA who are from, art and design, architecture kinds of backgrounds, and they make amazing contributions. We've got many athletes and then many people from very rigorous STEM backgrounds. So, whatever your passion is, there's likely a home for you at NASA or in space exploration with commercial companies. So you have lots of opportunities. So don't feel like you need to, satisfy all these requirements to be able to stamp the check to get into NASA. You can get to NASA from many different ways, including through community college and then transferring to a university, playing tennis, not doing any internships, and still being able to get into NASA. And then as far as the academics, my biggest advice to students always is to not lose focus when you start college. So many students think that the ultimate prize is being successful in high school and getting into that top-notch college, and then they sort of let off the gas pedal when they get into college and let their grades slip. And it becomes difficult to recover from that in your upper division classes later. So my biggest advice is to make sure you continue focus. The most important part of your career in STEM starts the day of your freshman year of college, and everything that happened before in high school is washed away, and you start fresh again in college. So you need to keep that in mind and keep the pedal to the metal with your homework and schooling, and make sure that you give your best effort starting then.
That is all brilliant advice. So thank you, Doug, for sharing that with us and for sharing your day with us as well. Just a quick challenge to our students. I want to tell you all about a heat shield activity where you can actually build your own heat shield and be a material scientist like Doug. We're going to drop that link in the chat so you can go check out that activity, and make sure you share your work with us at #NextGenSTEM. And make sure you also subscribe to NASA STEM Stars so you don't miss an episode in the future. And then next week's episode, we're going to be with George Jarosby, who works with the Diagnostics and Prognostics group at Ames. And that'll be next Wednesday at 2 p.m. Eastern. So that is all that we have for today. Again, thank you so much, Doug, for joining us. And I want to encourage our STEM fans to keep their foot to that pedal. And we'll see you again next week. Thanks for joining us.